Now, if you remember back to your Algebra 2 days, right, when we present this stuff in Chapter 9 of Algebra 2, rational functions, the first thing they talked about were points of discontinuity, meaning zeros of the denominator. If you plug in that value, you're going to get divide by 0, therefore it's a point of discontinuity on the graph. Then we divided those between vertical asymptotes and holes, right? It was a hole if the 0 divided out or canceled with a factor in the numerator, like that first example that I showed. But in a case like this, there's clearly a point of discontinuity at x equals 0. And it doesn't divide out with anything that's in the numerator. So this is the case for a vertical asymptote. Now, if you graph this, the shape of the graph looks like this. And you could see from both the left and the right, it looks like we usually see when we approach a vertical asymptote. It's kind of veering off towards infinity, which is what's typical of a vertical asymptote. Okay. So in this situation, as I'm approaching x equals 0 from the left, it's going to infinity. There is no limiting value. As I'm approaching from the right, getting closer and closer to x equals 0, the value of the function is going towards infinity. There is no limiting value. So when that happens, there is no limit, right? No limit at vertical asymptotes.